Astronomy, the study of the universe, is said to be the oldest of the sciences. What are its origins, and how is it developed? Ancient civilizations must have observed heavenly events such as the passage of days and nights and the phases of the moon. They saw that the cycle of the seasons was related to the position of the sun in the sky and the length of the day. From these simple regularities, the first calendars emerged, such as this one developed by the Aztec civilization of Central America. These calendars were useful for knowing when to plant or harvest crops, and also for predicting regular events such as floods. Large stone structures still exist, such as Stonehenge in the south of England, by which ancient societies could predict other events such as eclipses of the sun and moon. Stonehenge was built around 2000 BC by a Neolithic race with a long-standing tradition of celestial observation. The leaders of the people gained esteem through being able to predict eclipses and the positions of the sun and moon at different times of the year. One aspect of the sky which does not appear to change is the pattern of the stars. The first nomads may have used the stars for direction finding in their travels. For others, they were important for religious reasons. The ancients grouped together some stars into constellations. Often these were given names derived from imaginary pictures of creatures such as Scorpio, from a likeness to a scorpion. They recognized 12 constellations through which the sun, moon, and wandering stars or planets moved. This was the zodiac. The belief that the position of these moving bodies at a particular time affected events on the Earth gave rise to astrology. Hence, astronomy's origins are both practical and mystical. Astronomy first became a science with the ancient Greeks. Rather than simply observing the heavens or providing mythical and mystical stories about events in the sky, the Greeks sought explanations in terms of mathematical models of the universe. For example, one of the previous explanations of a lunar eclipse was that of a dragon eating up the moon. But the Greeks recognized that it was the Earth's shadow cast on the moon when both are aligned with the sun, as shown in the accompanying diagram. By noting the intervals, they were able to predict the time of eclipses and tell whether the eclipse would be full or partial. The Greeks also sought explanations for the movement of the planets. Under the influence of the great philosophers Plato and Aristotle, most Greek models of the universe were geocentric, that is, Earth-centered. In 150 AD, one of the last Greek astronomers, Ptolemy, presented the most successful of these models, consisting of an ingenious system of wheels within wheels. In Ptolemy's system, at left, the sun, moon, and planets revolved around the stationary central Earth. While the sun and moon had simple orbits, the planets performed more complex circular movements in the opposite direction. This system, although incorrect, can account for many observed features of a planet's motion. On the right is the heliocentric or sun-centered system. Although this system was actually first postulated by Aristarchus in 250 BC, it was ignored by most Greek astronomers and was only accepted when it was revived by Copernicus 1700 years later. With the coming of what is called the scientific revolution in the 16th and 17th centuries, a greater interest in astronomy resulted in more reliable observations. The most accurate observations made prior to the invention of the telescope were those of the Danish observer Tycho Brahe. Shown here is his graduated circle, or mural quadrant, by which accurate determinations of planetary positions could be obtained. Tycho's thorough observations were of great use when the German astronomer Kepler set out to find the true shape of the orbital motions of the planets. Kepler's discovery that the orbits are actually elliptical or oval-shaped led to a great advance in both mathematics and planetary astronomy. One of the great figures of the 17th century was Galileo, the first person to turn a telescope on the heavens. His observations changed many notions in astronomy. For example, Aristotle had believed that the celestial bodies were perfectly spherical objects made of a pure, crystalline substance. Through his primitive telescope, Galileo saw that the moon had an uneven surface with craters. He also observed Saturn's unusual shape, which we now know is due to its rings. The revolution of the moons around Jupiter showed that not all movement in the solar system was around its center. Sir Isaac Newton, born in 1652, stands as the greatest figure in the advance of astronomy and science in general. Newton unified and extended all the knowledge that had arisen since the time of Copernicus, creating a system of mathematical physics of enormous scope and insight. His laws of motion and universal gravitation systematized the position, motion, and interaction of every particle of matter in the universe. Newton also invented the reflector telescope. Instead of direct observation of stars through the lens of the telescope, light was received on a concave mirror and reflected onto a central observation point. This development added greatly to the amount and quality of astronomical data that is the standard design for all modern telescopes, both optical and radio. Astronomical observation flourished after the time of Newton with larger telescopes and more precise optics. Here's the 2-meter reflector, which William Parsons, the Earl of Rosse, built in 1845. This telescope had a concave objective mirror made of polished metal and was one of the largest of its kind. Modern optical telescopes are even larger. Here's the Anglo-Australian telescope at Siding Spring, New South Wales. The telescope is mounted on a giant horseshoe-shaped bearing which allows it to track stars as they move across the sky. The main mirror, 3.9 meters across, is made of a ceramic glass coated with reflective aluminium. The AAT is typical of the latest generation of optical telescopes around the world, with mirrors up to 6 meters in diameter. But optical telescopes are not the only type of astronomical instrument. Since the Second World War, a number of different types of radio telescopes have been developed. Some have shapes resembling the mirrors of optical telescopes, only much larger. Radio telescopes in general have added much to our current view of the universe, being able to detect sources such as clouds of dust and gas which exist between stars and which give off no visible light. When we combine the findings of modern telescopes with observations from space, we realize how much our view of the universe and our place in it has changed. More so in our lifetime than at any time in history. In the next few pictures, we'll try to comprehend the present view of our place in the universe. Modern astronomy involves distances and times which are difficult to conceive. The Earth is part of the system of planets revolving around the Sun, the solar system. The solar system is 12 billion kilometers across. In astronomy, we need a more convenient unit to measure distances. Light travels at 300,000 kilometers in a second. To cross the solar system, light would take 12 hours. In other words, the solar system is 12 light hours across. The light given off by our sun shines out into the universe just as the light of other stars reaches us. But traveling at 300,000 kilometers every second, it takes 4 years to reach the next nearest star. So its distance is 4 light years. Here we're looking towards that part of the night sky where stars appear most dense, the Milky Way. Most of these stars are up to 20,000 light-years distant. This dense band of stars stretching across the sky appears to encircle the Earth. This places us within a large group of stars called the galaxy. If we were able to view our galaxy from a distance, it would look something like this. It was only in 1950 that astronomers, particularly radio astronomers, were able to confirm positively that our Sun was part of a galaxy with spiraling arms like this one. Other galaxies have different appearances. Over 100 billion stars make up our galaxy. This distance from one side to the other is about 100,000 light-years. In our galaxy, the Sun is located in one of the arms about 30,000 light-years from the center. It's only in the last few decades that astronomers have realized just how many galaxies exist, as more and more powerful telescopes are brought into action. Present estimates calculate the number of galaxies which can be detected at several million. The light from the nearest spiral galaxy to our own takes about 2 million years to reach us. Most of the galaxies in this photo are well over 100 million light-years away. The most distant galaxies observed are of the order of 4,000 million light-years away. If their light takes so long to reach us, we can therefore only observe distant galaxies as they existed a long time ago. So our modern view of the universe is indeed humbling.